Okay, so the first thing we need to do is find where we stored it. So I installed mine in C, Program Files, GUI Windows, and then you need to double click on Application. For the first run through, we're going to need to run as administrator, basically so we can add the SSL security certificate into the MATLAB runtime Java virtual environment, which will basically allow us to access the database from a Windows application. You will not have to do this for an OS X or Linux version of my application, just Windows. So basically, we now need to link an SSL certificate, so we need to get it first. So if you go to https://finds.org.uk/database/images, click on the padlock, click certificate, then details, then copy to file, and next, then we're going to need to save it. Let's just call it cert2. Click next, finish. Okay, so now we've got our certificate. Back to the application, click link SSL certificate, and then basically wherever you saved it, click there, then open. And then once that's done, you're going to need to restart the application for the changes to take effect. So close it and reopen it. You don't need to run as admin anymore. So there you go. So it's open now. So basically the first feature, upload image. Basically we're going to need to find our image. So there we go. Basically upload it to the application now. The join images button will allow the user to basically join two images together. Nothing special, so there you go. Join. And then the first noticeable bit of my application would be the extract features. This basically uses texture segmentation on the image to basically separate the textures. This can take a while to compute, mainly because of all the operations what need to be performed. But it's still probably quicker than manually removing the background if you don't know what you're doing, like a normal archaeologist. There you go. Now you can see the two textures has been separated. Obviously this isn't perfect. As you can see, it's lost the top of the medallion there. So basically that doesn't really matter anyway. Neural network's probably not going to recognize it as a medallion because it's lost, well, its most identifying feature to separate it from like coins and bullets and stuff. So once we've done that, we can save the image we've just did. So basically the user doesn't have to do it again. So basically save image, pictures. We can save it as a variety of different formats. Call it picture, then click save. So now our picture has been saved, as you can see there. Right, the next one would be the smart search. This uses a neural network I created to try to identify what it is, and obviously isn't 100% accurate because there's no such thing as 100% accurate neural networks yet. So based on the input image, the neural network thinks it could be a box fitting, a bullet, coin hold, blah 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 blah. And then if we scroll down, you can see that they're already ticked for us. And we can add ticks, remove them obviously. Now what the update list button does is basically these categories here are direct from the database. So update list basically makes the application include the categories from the database. So if they've added a date category, it will be included in this list. Removed it, obviously it'll remove it from this list. Changed its name, and then obviously the name will change here too. But yeah, that's basically what it does. Now, because I know this is a medallion, and basically to save time during the computations, I'm going to need to find medallion, so there it is. So, do you want to use surf for the results? Ideally, yes, because using the similarity and correlation is both time consuming and not very accurate, so let's use surf. The similarity and correlation is only in there basically because it's in the project brief. So now we need to wait for it to download 700-800 images and compare the results. So there you go, so it's done now. So Our best match has no name in the XML, but it has 49 matching features, and it has a URL. So let's follow the URL. Just copy and paste that into the browser. And this is actually what I've uploaded. I basically robbed an image off Google, basically so I would know it would match a medallion in the database. Well, not know, but whatever. So basically from that information, I cast, it's a cast white metal religious medal from post-medieval period. From the 19th century. One side has Jesus on it. And we've basically got how much this one weighs and its diameter. And obviously we've got the periods and where it was actually found on the map, including the coordinates. And then obviously you've got similar objects. So other ones which were closer, which were deemed in the top 5, should I say, were this one, which isn't very similar at all. And the least similar one would be this one. But obviously we actually have what we need anyway, so the reason why these results may vary quite a bit is because those 600-700 images, we don't really know what they look like, and they could be all shapes, sizes, and colors. And obviously this one was the closest, and this is the actual one we need. So basically, the difference between the two images. So it's correctly classified that image. Another feature worth mentioning, which I haven't used yet, is the background subtraction one. Also aims to remove the background from the image, so we go need to upload an image of the foreground first. And then we're going to need to use the background subtraction. So let's upload the background. And then we basically can just adjust the threshold. So let's try 5. Nope. Then go higher, so 10. 11. Oh, there you go, try 15. 14. And as you can see, there's some noise around the side. Well, we can remove the noise. We'll basically... There you go, once the noise is removed, you can just click finished. And there you go. The coin with most of the background removed. And that is basically my whole application.